Morning, guys. Please let your friends also know to start this session is started. Okay, let every of your friends to know the join session. And the attendance is mandatory, so make sure to join every day.
Good morning, everyone. I hope I'm audible. I'm just going to start the session right now. Just wait for 1 minute. We'll start the session. Good morning, everyone. I hope you're doing well. So let's continue the session today. So till now we discussed about the things like how this text is going to be generated, right? So what is the thing means? So now we'll go and deep into dive. So we're going to understand the concept of how this generative AI going to work. Okay. So till now you have seen that how this generative have took place. Okay. So now from here we're going to see that how image going to be generated, right? So till now just we discussed the different types of things like how it is going to work, like text, how it is going to split it, and how the machine were going to understand the text, right? And how it is going to generate. But from here we'll go with the understanding of image. Okay, so we have seen a n number of models, the image is going to be generated. So then how this image is going to be generated, okay, we'll see and we'll discuss those things in this today's session. Hope I'm clear, guys. Okay, don't worry, you will get the recording sessions. I'll provide the recording sessions, don't worry. Share my screen. Guys, the screen is visible. If not, just let me know. That's good. So before moving to the generative model, so what is this? Anyone can please let me know what is discriminative AI and what is generative AI? What is the main difference between both of them? What is discriminative AI? What is generative AI? Anyone? Okay. Devansh. Okay. What is the thing about discriminative AI? Okay, that's correct answer. And what is generative AI? Yeah, that is a correct. So moving forward, just we are going to see that what is we have seen that what is generative AI, what is a discriminative AI. Discriminative AI, it is going to do the process, it is going to perform the operations on prediction. It's not going to give any out of the syllabus, right? So it's not going to give provide us an out of the syllabus, means like it is not going to provide us out of the box information, whereas this generative AI, it is going to give the information from out. So this is the main difference. So discriminative will revolve around the uh, uh, tasks. So for example, what are the tasks you are expecting? It is going to give the same output what you are expecting. It is going to predict the next output based on the previous, because you train the model on that way. So it is going to predict, it is going to classify in different format. So whereas coming to generative AI, it is going to generate according what you are expecting. It is going to give the same, but it is going to generate adding something new to it. For example, you ask for generative AI to give a how was the weather tomorrow. So if the some of the models are integrated to that LLM, then it is going to get the access from right now what is the temperature outside, and based on that it is going to add something like this. So today was temperature like this, it was cloudy and it is going to rain today, and it was rained these 2 days back, and it is going to give that information. But whereas coming to prediction part, it is going to say that tomorrow is going to rain or not. It is going to give only the one word. Okay, if it is rain, yes, tomorrow is going to rain, or not. If sorry, not going to rain tomorrow. So in that way, it is going to give the previous based on previous data. So in that we'll discussed about RNN, LSTM. So what will it will do? It will help the model to generate the next word. Means it will process that fast and it help the model to generate the next word. So okay, till now we seen the generating of the next word. Then how this image has been generating? Okay, how the model is understanding to generate image. See, if there is architecture, means there is a artist, we'll say general, right? So is what is general going to do? Is going to sketch some new arts, right? Is imaginary things he's going to put on a paper, right? So it's going to give you new life, new images, right? New characters. He's going to art. So in that, how the human is thinking, how the human is generating a new paints. In that way, this generative AI is going to think and going to generate the new samples. Okay. So let's say before going that, how this model is going to work means in the background, it is going to use some neural network concept. Okay. So before going to the generative AI, GANs, we are going to see a one prediction model. That model had some layers. That model had some layers. That layers are used in this generative. So before then, just let me explain that what is CNN. CNN is a part of predictive discriminative AI, which will help to predict the next image, like the image captioning or image classifying. So these tasks are going to be done by using the CNN. But you, while doing with the CNN, there are some layers like convolution layers, okay, transpose layers. So using these layers, the model is trying to predict the image. It is going to try to give the caption to the image. So by using these layers, so these layers are going to be used in generative AI, means GANs, which will help the model to understand more, which will help the model to understand more about images. Okay. CNN is a convolution neural network. Okay, convolutional neural network in a deep learning. Okay, so we'll explore this and we'll understand and we'll move to the next GANs. Okay. So coming to the machine learning, so we already know that what is machine learning, right? So what is generally the machine learning will do? Machine learning is going to be deal with the predictive models, and it is going to deal with the data type. Supervised, unsupervised models is there, and reinforcement learning is there in machine learning. So using these machine learning concepts only, that deep learning has been divided. So how means, for example, the type of data we call. So for example, there is a images. Yeah, there is a 100 images of cat. So is this supervised or unsupervised data? It's like labeled data or unlabeled data. There is a 100 images of a cat. Is this labeled data or unlabeled data, guys? Yeah, absolutely, it is a labeled data. So how we are saying that this is a labeled data and this is unlabeled data? Based on the output, based on the predict value. So we are expecting y, right? We are specifying y, means then we call it as a labeled data. There is no y, means they are not specifying any kind of data. It is, they are not specifying this is a kind of data. If you say that this is a kind of data, means we'll say it is a labeled data. We can't say this what type of data it is, means it is a unlabeled data, right? So using this data, we are going to perform different operation in machine learning. So we have no supervised, we have classification regression models. As unsupervised, we have clustering and PCA methods, and reinforcement learning is a other type of learning. So these are the different types of learnings we have in machine learning. So in application of machine learning, so why we need to know machine learning means it is a main branch, right? So main thing we need to know. And deep learning is a part of machine learning. So Gen AI is a part of deep learning, right? So it is a part of other stream. So that is the thing we need to know about the main. So application. So we can see that using machine learning, what are the things we can solve, means like self-driving cars. In a self-driving cars, it need to take the immediate decision based on the front view. It need to take the decision that it need to go to right or left, right? And spam detection mails. So how the model will understand that this is a normal mail or a spam mail? So it need to identify, right? So this type of task we can perform using this machine learning. In that, we have already know the classification and the regression. So what is the classification? Classification is going to classify the things. So you can see in the images that there is a image of cat and dog. So how we can classify based on some features, right? Cat has different ears and dog has different ears, and we can see that we can see that there is a number of differences of between a cat and dog. So we are classifying this is a cat and this is a dog. So when we say the data is going to classification data as a prediction model based on the output, whatever output we're expecting, it is a categorical data or not, based on that we are going to identify. Coming to the regression part will help the model to, if the value is continuous value, what is the value we are just checking, that is a continuous value, then we go with the regression models. Then we will go with the regression model like house price prediction or like stock price prediction, because the value is going to be comes continuously, right? So it's not going to repeat. So in that way, we say it is a regression models. Okay, I hope these things is clear, right, guys? Yeah. So coming to the deep learning, till now we discussed machine learning. So now we are entering into the deep learning. So why this deep learning? So deep learning also will follow the same rules how the machine learning is following on the data. It had same like unsupervised and supervised data. Okay, and supervised models and unsupervised learning models. So, but the difference between machine learning and the deep learning, machine learning do the calculations and perform the operation based on statistics. Whereas coming to the deep learning will follow the statistic as well as, but it is going to deal with the neural network. It mainly specialized in neural network. So why we need to go with the neural network? Why we can't do with the statistics means some, whereas the complex data came into the picture. Complex data means the type of image data, because image going to have huge number of pixels, right? In a one image, they're going to be have n number of pixels. So for performing that operation, it will take too much time, right? So if there is a crores of images, so how much time it will take to the model to do the process, right? So that is the thing, they introduce some more complex technology that we call as a neural network. How human brain is going to work in the same format, they are construct artificial neurons. Okay, so using these neural networks, the operation, the generative AI or deep learning is going to work. So in the diagram you can see, guys, so this is a neural network. So how it they inspired from human neurons means, generally we are going to get a input, right? For example, your hand is you want to carry a glass, you want to catch a glass to drink a water. Okay, glass of water you want to drink. So what, you're going to pass some sensors to your hand. Your brain is going to pass some sensors to your hand. You're going to pick that glass, right? You're going to pick the glass. So how we are passing sensors in the format, they introduce this neural network. That sensors is nothing but input. We are going to give the input, right? It may be type of image data, video, audio. Okay, we are going to pass that input, and the hidden layer is going to have carry the one hidden layer where it is going to perform some calculations. Okay, and before doing the calculation, it's going to deal with the weights concept. So what will these weights will generally will do means, these weights will do the calculation, means they're going to perform operation like computation, so with the weights, and it is going to give the output. Okay, guys, so this is an entire process will happen in neural network. We call it as an artificial neural network. We named as a ANN. Okay, guys, so with this AN you can solve only the simple task, like it may be CSV data, it may be text data, you can solve. But whereas there is a complex data, I already said that complex data is going to deal with the image. Okay, so if we had that much of big images, then how this ANN will handle, right? So to overcome that issue in this ANN, they introduce that CNN, convolution neural network. Okay, you got, guys. So why they introduce CNN? So this is a CNN which is going to, till now it is one of the best model in dealing with the images. Okay, so what it had a specialization, why we need to consider this CNN means, it is one of the deep learning model and specially designed for image recognition tasks, specially designed for image tasks. So what are the image tasks you have this, you can go with this using CNN. Okay, why CNN means, it is a very efficient and process the things, right? So we have seen that in our ANN we had, what are the layers we have? Input layer, hidden layer, and output layer. So when someone asks that what is perceptron, single perceptron, you can say that the single perceptron is going to carry only one neuron, that is input, hidden, and output. Okay, so if we had that, it's going to do the simple calculation. But to do the complex calculation, they introduce CNN. So what the CNN has means, CNN is specially designed for image processing, as well as it has different specialized layers. So what the layers we have, so we'll discuss. And where are the applications, like recognition objects in images with the high accuracy. So it will perform well on analyzing these images. It will perform well on analyzing these images, guys. Okay. So this is the architecture of CNN, guys. This is the architecture of CNN. So what this architecture means, input raw pixel enter the new network. So means nothing but first we'll pass the information, means we'll pass the input data, like it may be image. So you can see in the first one, so in architecture we are passing a car image, right? We are passing a car image. Before passing, the model has been trained with the huge amount of data, guys. Okay, before passing this car image, the model has been trained with the huge information. Okay, now after passing the input image, the raw image, so that image is generally going to convert into numbers. Okay, after that we had one of the layer, that layer we called as a convolution layer. Okay, generally in any of the model they're going to deal with the layers, guys. Okay, layers is nothing but the which is going to carry the neurons. Okay, it is artificial neurons, no, that is the thing we're going to say as the layers. Okay, so next layer is nothing but convolution layer. Okay, convolution layer. So what this convolution layer will do means, so you can see that in the top there is an image with the different colors, right? in the top of convolution, in the below of convolution, so there is a different type of image. So what it is saying for us, so we can't do anything because that the human cannot understand that because there is a multicolored image. So but the CNN can understand and it will observe some features from this. It will extract some features. So the CNN going to use some filters, guys. Okay, it will use some filters, and we say it as a kernels. In CNN, it will a convolution layer. It will use some filters. We say it as a kernels or filters. Okay, with a different size. So what this it will do means it will apply that filter on complete image. Like it had 80-90 filters. Every filter go and it will apply the in complete image. It will apply for example, this is my image. Okay, this is my image. So first it will take the 6 pixels, means top 3 and down 3. Okay, so this is my image, like 3 into 3 pixel filter I had 3 into 3. I'll apply the filter in the top of this image and it will extract some information, and that filter will move for one step and it will apply again, and like this it will move complete image. It will move the complete image. Single filter will move the complete image and it will give the some information. Like this 60-70 filters are going to apply on the image, and that it will give the different features to the next layer. So next layer, what it will do means it will combine all the information of that image and it will minimize the image, means it will reduce the size of the image. How it is going to reduce? For example, first filter gave the information like numbers, because it is going to deal with the numbers. No, for example, I'm just saying that 4 5 6 7. So it will, what is the highest value here? 6 7, right? 7 is highest value. So in pooling layer, like this, every pixel which had highest layer, means like max value. Okay, it's going to get max pooling layer, we say generally. Okay, so it's going to pull the max value and make it as an image. So you can see in that here applying one convolution layer, the image has been reduced. The image has been reduced the size, right? After that, it is going to be applied some more filters. Again, it will use a one more convolution layer, and that is going to be extract some more information. Like this, it will process till entire the image is going to be it is going to make it as a 1D vector, means a single row values. How it is going to use one more layer, that is fully connected layer. It's going to use one more layer, that is a fully connected layer is going to use. Here, using this fully connected layer, what it will do means we have in the dimension format like 2 into 3 dimension, that is going to be converted into single vector, 1D vector, we say. A 1D vector. It is going to be converted these vectors. So every cell, so you can see here in the third one, you can see here, observe here, flatten layer. In the architecture, you can observe, guys, it has a name as a flatten and fully connected. So applying flatten after the fully connected layer, these fully connected are passed to the neurons. Now we have again we are going to have some artificial neurons. That neuron, every neuron will carry one pixel value. Every neuron will carry one pixel value and will process and going to give the output, and it is going to define. So here you can see in the output we have the different vehicle names: car, truck, van. So based on this image, it need to identify which type of vehicle it is. So it's going to classify that is a car image. Yes, guys, hope you're clear with this. So this is how this architecture CNN is going to work. So it's going to have the input layer and convolution layer, pooling layer, fully connected on the output layer. So in the previous, in ANN, artificial neural network, we had only 3 layers: input layer, hidden layer, and the output layer. Whereas in a CNN, we had a different type of layers: convolution layer, pooling layer, fully connected layer, right? This is how the image is going to processed in layer by layer. So I already said, so it's going to apply some filters. It's going to apply some filters on data and image, and it will process and it will extract the some important features. So mainly these filters will focus on edges, guys, edges and shapes of the image to give the best output. So there is a different concept like activation function. So this activation function, why this activation function will do, what is the use of this activation function? In the previous I think you have observed, so in a convolution layer plus with the ReLU, you can observe there is a small word with the ReLU, ReLU, and you can see here also ReLU. And have you observed here the last layer them named as a softmax? Why this they did do you know? Because while processing, they're going to have different activation functions. These activation functions will help the model to learn complex things. Okay, so while processing, it will learn. So ReLU, how this ReLU is going to generally work means, this ReLU will help the model to give the outputs, means the neurons going to be deactivated, which was in a negative value. So whereas there is, for example, there is a 10 values, in that we have 2 values are negative values. So this ReLU will deactivate that negative values and make it as a positive, and other values which are the 8 values are positive, that is going to pass for the next layer. So this is how the ReLU will make the data complexly. The model will not focus on unwanted data, it will focus on important features, guys. Okay, that is the thing it is going to do. And next, coming to the softmax, the softmax is going to based on the activation function, which is going to based on a probability distribution. So which, after doing the classification, last layer going to give the probability of each class. Last layer going to give the probability of each class. So which class had a best probability, then it is going to identify that is the image is going to belong for that class. The image is going to belong to the that class. So it is going to identify in that way. Okay, so if there is a multi-class classification, multi-class means the y value need to have n number of values. For example, in the previous we have cat and dog. There is only two binary classification. If we have like 5-star rating means we are going to have 1 star, 2 star, 3 star, 4 star, 5 star. So we have 5 different classes. So for that, binary classification is not going to work. We need to go with the multi-class classification. Like we have, for example, you have in a y, we have a 30 class classifications. Means we have 30 classes, then you need to identify the image belongs to which class. So in that area, this softmax is generally going to be used. Okay. So here you can see that pooling layers, what is the things is going to do in a pooling layer. There is a different layers of pooling layer. So reduce the dimensionality while preserving important features, while extracting the important features from the image. So they do this task, guys. Okay, they perform this. And max pooling means, for example, there is a box, in that there is a 4 values. I already said that. So in that, which value is a max value, then that value is going to add it for the next layer. In that, for remaining 3 is going to be neglected. So like this max pooling going to work. Whereas average pooling, so they will add all the sum by all the things, and number by number it is going to give the average value. So you can use whatever you want in your layers. So that is the way how it is going to work. So dense and output layer. So these are the different 2 layers. I already said the dense layer is nothing but fully connected layer. Fully connected layer means it going to convert all the pixels into one layer, single layer, and that is going to be transformed for the next layer as a neuron by neuron. So every pixel value is going to be sent for one neuron. Okay. And finally, output layer, the softmax will decide on which class this it is going to decide. These function, this multi-class classification generally is going to use softmax. If it is a binary, then you can use a sigmoid activation function for final classification. So final output, you need to use any of these activation functions. Okay. In real world scenario where we can use this CNN means, you can use with face recognition area. In face recognition, you can you're going to use the CNN, and like self-driving cars, and medical imagination. So for analyzing the person also, you in the medical industry, we are going to use the CNN. So it will help the wherever the need in a complex way, where it need to be solved in a complex format, then we are going to use this CNN. Okay. So that is about the CNN. I hope this clear with you guys, right? So that is about CNN. So we'll discuss now what is GANs. So one of the generative model. So we are dealing with the generative AI. We'll discuss one of the model is GANs. We'll go with the GANs now. So I hope the screen is visible, guys. Is it okay? Is this visible? The screen is visible. So we discussed about CNN. So why we discussed the CNN, we'll get to know in this topic. Okay. So what is GAN? So why we need to understand this GAN? So GAN is nothing but generative adversarial network. So the name is suggesting that it is going to generate something. Okay, it is going to generate something. So what it is going to generate, we'll see. And adversarial nothing but it is going to add a conflict between the networks. Okay, so generative is going to do something like generate something, and adversarial is nothing but it is going to be act like conflict between two things. Okay, two networks. So conflict means every time they're going to have some war between two networks. So what is that, we'll see. In this is one of the deep learning technique, and it is mainly used in a generative task, which is going to use deep learning, and it is going to generate new things. Okay, so the architecture of GANs, you can see that there are different types of things is going to happen in GANs. Using GANs, you can do a number of things. I think in the previous past 2 years, 3 years ago, I think so. So there is a one application become famous in social media. Like, so if you give a baby photo, after 60 years, how it is going to look like, the baby is going to look like, it's going to transform that kid into the after 60 years, how it is going to look like. So that images is going to be transformed. So how these things is going to happen, how it happened means using these GANs. So when the GANs has introduced that, it became one of the popular. Okay, so in GANs was introduced in 2014 by name of Goodfellow. So who has introduced these GANs. From that it became one of the popular model. So it had three different things in GANs. One is a generator, another one discriminator. So this is a thing is going to happen. The adversarial loop is going to happen means conflict is going to be happen between generator one network, discriminator is other network. So between these two networks there is going to be a war between these two networks. Okay, so that is the thing they named it as a GAN. So you can see here there is a person name as an original image. Okay, this is the original image. First image was the original image. After that, he has just did some things like it's converted to inverse, means like right to left, left to right, right. So it has been worked. It has been changed the things. After that, you can see it's age. So you can change the person age. You can increase the age and decrease the age using these GANs. Okay, so that type of operation also it can perform. And expression, see is in these three images there is no expressions, but you can hear that image, the person is laughing, right? So in the last you can see eyeglasses you can add. So I think you have been used this, who had glasses. I think you have gone through the Lenskart application. If you want, you can try, guys. So go to Lenskart in your Chrome browser, and it will show you that different glasses. If you want to use that glasses, you need to capture your image, and after that it is going to show that is that glasses is going to be suited for you or not. It is like it, you can analyze. So like this you can perform n number of operations using these GANs, guys. Okay, so what this generator will generally do means we'll discuss. Okay, for example, how this GANs is going to work, let me give an example. So there is a person who is a artist. Okay, he's trying to draw an image. Okay, he's trying to draw an image with the, he's known some features. He's known some features. Based on that, he started drawing some features. Okay, so after that, there is a person who is act as a detective. Okay, there's a person who is going to act as a detective. After this person who has as a, there is an artist drawn something, so he's going to identify that. So how he had drawn, so how was the images and how was the real image, he's going to identify the difference between the real image and the artist which has been drawn that image. It is going to analyze by one of the detective. Okay, so this is the thing is going to happen, guys, in generator. I hope you got a clarity. In the moving you'll get more clarity about this game. Means, see, first the artist is going to have some unwanted data. Okay, means like he's going to have some sketches he just painted on this paper in a different format. and just he started that making a good structure, is trying to give a good structure for that image, and he completely finally finished that art. And where this art is going to be, for example, you can go for an exhibition, so they what they'll do, just they're going to check that this art is in a good format or not, so they're going to see. So in that way, this detective going to check that which one is real and which one is fake. So here the generator will do this task. So when the user will give the noisy data means the data is not going to carry any information, like it is in a raw data. Okay, so that data is going to pass to generator which has its previous experience. Based on that, it will try to generate image. Okay, it will try to generate image. So that image is going to be checked by this discriminator, guys. Discriminator, what it will do means it will take the input real data. Here for generator, we are not going to pass any real data, guys. Just we'll pass the real data for only the discriminator. Discriminator also already is going to be trained on that real data, so it's going to analyze so which one is real and which one is fake. So the main game, I said no, that conflict is going to happen between this generator and discriminator is that generator is trying to do a fool of discriminator. Generator is trying to make the discriminator fool. So this is the how it is going to make the fool. It will try to generate the realistic image. It will try with n number of times to generate the realistic image, and finally if that real image is matched with the fake image which was generated by generator is going to be matched, then it is going, discriminator is going to be get confused which one is real and which one is fake. So that is the main task of this generator. Okay, you can see one more example. So for example, there is a notes, right? So there is a huge notes which is going to come in a market into the fake notes, right? So you just develop that the model which is going to generate the fake notes. So the model need to be alert. So just you send a noisy data. Noisy data means it's not going to carry any information, guys. Okay, make sure that it is a like single vector, randomly added numbers vector. This is a noisy data. Okay, so that is passed to the generator. So generator started generating a fake image after running out 20-40 times. It started giving a one image as output. Okay, so that image is passed to the discriminator. That image is which has been generated by generator is passed to the discriminator, and these real data, real notes images already passed to the discriminator, and the discriminator already trained. Is it ready? It's ready. Okay, now when you pass the fake data, this model will understand, this model will analyze which one is real and which one is fake data. This model will try to find which one is real and which one is fake. So after finding that if it is no fake, then that classification is going to send to the generator. So you did the mistake. This is a difference between real image and the fake image. So then generator will update, as well as discriminator also will update with that loss. And okay, so this will happen, and again this generator will work and it will generate the fake image, and that is going to send to the discriminator, and discriminator will process and going to give that which one is real and which one is fake. So this is a game is going to happen between generator and discriminator. So why they introduce this concept like generating and identifying which is fake and real? So for example, in the previous section we discussed, right? In the previous section we discussed about CNN. So what the CNN will do, will pass thousands and 10,000 of images. Based on that images, CNN is going to be learned, and this CNN is going to be predict, right? Means predict means it is going to say the type of images, which type of image it is, right? So if I change the data, for example, you are working on a project that I need to predict. For example, there is you are working on a traffic control. Okay, in that you used a CNN model. Okay, what it will do, it will check the each and every image in the traffic. So is that it is need to identify that is a heavy vehicle or normal vehicle. Means how it is going to say the persons who is going to passenger, that is a normal vehicle. The loads with the heavy lorries will come, no, so that we will say it as a heavy vehicle. So you just found a model, just you implemented CNN model in your project, guys. Okay, you prepare the model with the huge data. The model has been trained and you will get the good accuracy. The model is working well. So when you pass any image, it is saying that this is a heavy vehicle or normal vehicle. Okay, so this is the thing is happening. So what I will do, I'll just go and change your data. What I will do means I will add huge amount of unwanted data like ships, aeroplanes in your data. In the vehicle, you're going to deal with the ships and aeroplanes? No. But what I'll do, I'll just add this data to your data set. So the model is going to be trained on that data also. It get confused. Is the boats and aeroplanes are the real heavy vehicles? Yes, but they are not going to be travel on the roads. So it will find further. Means it will forget about lorries and heavy vehicles. It will try that if there is a vehicle like aeroplane on the roads, then it is say it is a heavy vehicle. So if that the model is working in the right format, is the model is generating in the right format, it's like working and predicting in the right format? No. So this is a thing is going to happen in the models. So to overcome that issue, he introduced this that. So when this generator generating a new image, there will be a one person who is going to check that the image is a real image or fake image. So now if you change the data, you're just providing only noise data, then no one can uh, defeat the model. Means in some scenarios, it may the model get in stuck in mistake. Means it's going to perform, not going to perform well in a predictive. So that is the thing. While dealing with these GANs, they introduce this generator and discriminator to their models. Okay, guys. So generator network, how is going to work? Okay, we'll discuss this. Okay, before that, have a 5 minutes break. Okay, we'll discuss this. What is noisy and all the things. Okay, 5 minutes break. I think you're clear with this generator. It's like so discriminator, how it is going to work. Generator, we'll discuss how this generator going to work and what is the CNN will do, what is the key role it will play. Okay. Guys, am I audible? Just you know. Okay. Just faced some technical issue. Sorry that. Okay. Let me share. Let's continue that remaining part. I hope the screen is visible, guys. So coming to the next part. So generative network, how it is going to work. So till now we discussed about CNN how is going to work and what are the layers we're going to have in the CNN, as well as we discussed the GANs. So how the between adversarial is going to happen between two networks, as a conflict is going to happen between two networks. So we have seen. Now we'll see the in detail about each part. So this generator going to carry with a ZZ value, means nothing but first we are going to pass a random noise. It will start with the random noise of starting point. So we'll pass the random noise to the day model, means generator, means it will carry the 1D vector. It may be 512 values. It contain more than that. Okay, so 1024. So like this, you can give the n number of values based on the data that is a randomly generated data. You're going to pass to the model will analyze what are the, while training, what is it has been learned, so that is going to apply it on this data and trying to perform the operation. Next, after passing the input noise data to the model, next it will go with the dense layer, guys. So in this dense layer, what happens? It will start reconstructing. So first, what type of data will pass? Will pass noise data, right? So noise data in a format of one flattened 1D vector. It's not going to have like a image shape. Okay, it will pass generally in a 1D vector, like a serial single row. Okay, so that row need to be converted into dimensions, right? That row need to be converted into dimensions. So that dimensions will start by using this dense layer. First, it will start 2 into 2 dimension matrix, and after that 4 into 4, 8 into 8, 16, like 34, 64, 128. Like this, it will increase on and it will make it as a complete image. And after that, converting that image, next it will pass to the transpose layer. So in this transpose convolution layer is nothing but we use previous CNN layers as a convolution layers to add best features. We will upsample the image. First, we have a small image like 2 into 2, 4 into 4. No, so every time while performing the operation, it will upsample the image. Means it will add some more elements. 2 into 2 will convert into 4 into 4. Means it will add in the important features in a row by row and step by step. Okay, so now like this, the what are the information we had? Just it is going to be upsample previous with the previous past information, and it will convert the it will generate the fake image. While generating, you need to give the output image size. For example, your discriminator, you're expecting a cat image. The cat image size was 28 into 28 pixels. Okay, length and height was 28 into 28. So you need to give the output image from the generator. You need to give the 28 into 28, because if you are not going to pass the actual image, so then the discriminator never accept, because that is the discriminator image size is 28 to 28. The model is generating 34 into 34. Then is these two images going to match? No, never, right? So that is the issue. To overcome that, in the last layer, you need to pass the correct accurate size of the image. Okay, so this is how generator going to carry the different layers and perform the operation. So layers in generator. So you can see that first we're going to give the noisy data as input vector. Noisy vector means single vector, starting point for the image generation, and will pass for the fully connected. That information will pass for the next as fully connected layer. So in this dense layer, it will start shaping the image. It will start shaping the image, means upsampling the image. So if you take a small simple image, it will convert into next as a some size like 2 into 2 convert into 4 into 4, and it will upsample the image layer by layer, and after that it will pass to the convolution layer. In this convolution layer, it will give the exact features. It is going to add some more features and upsample the data, and it will generate the image. So coming to the discriminator. So what this discriminator generally will do means it need to say that the image is real or fake. See here, you can see here the two images. There are the two images. Is this two images are real images? No, because one is real images. Consider that left one is a real image, but right one is a fake image, because the image looks like same, but the color was different. The image looks like same, but the color was different. So in this discriminator, what we will do means, in the previous generator, just we trained, but we are not give the exact image information. It's we in the encoder decoder, generally what it happens, it will give the decoder to reconstruct the image with the features, main features. Okay, there is a concept, I think you are clear with the encoder decoder concept. So in that encoder decoder, what happens, encoder will extract the information from the image, and that important features pass it for the decoder. Okay, decoder taking that information, and it will start the reconstructing again image, it will reconstruct. So, but here we are not going to pass any information for generator. Just we are going to give the unwanted data, and will ask you that model to generate the new data samples. Okay, so this is the thing is happen in generator GANs. So here we are going to discriminator. What it will do means, it will act like a classification model. It will act as like a classification model. Means it is a act as like a binary classification. It need to do, what is the binary classification it will do? It will say that the image is a fake or real. Only two things we have here. That is the thing we say it as a binary classification. Input images will pass the real input images, not fake images, real input images. Using that images, it will use the convolution layers. It will use a convolution layer. Okay, so using this convolution layer, it will extract the information from that image. It will extract the information from the images, and it will decide that it's going to carry some features. When there is a new image come from generator, it's going to say that it is a real image or a fake image. So what are the different layers we're going to have in the discriminator? It is going to have the convolution layer. As well, we know that what the convolution layer will do, it will extract the information from the data, as well as we have activation functions, which will help the model to understand complexly, too complexly. And connector layers, so these connector layers will carry the features of information which has been extracted from convolution layer. So it has been going to carry complete features, and finally based on these features only it will classify that is a real image or fake image. Okay, so this thing is going to happen in discriminator. And this discriminator is going to do that operation. Not only this GANs not only going to perform on images, it will perform on text data also. So it will perform on text data, audio, video also. It can do the operations using this GAN. Okay guys, coming sessions we will see the practical also on this GANs if possible. How GANs learns and training process. So generator improvement fools the discriminator more often. So what this generator will do, generator try to generate the new image while generating with the n number of times. Generator will go into the loop and try to add some more elements, some functionalities. Every time it will update and it will generate the image. Okay, ZZ of using noisy, it will try to give the ZZ output. Okay, we call it as a random noise data as a Z. So when we pass this Z to the generator, generator will generate the ZZ as a image, fake image. So the discriminator will take and it will classify which one is real and which one is a fake image. Based on that only, it will produce the some loss, right? So when it is say that this is a fake image, then the discriminator says some loss. That loss is passed to the generator. And discriminator will get that loss, and this generator will update based on the discriminator loss. Okay, based on the discriminator loss, generator will update and it will run again multiple times and will try to generate again. Okay, and there's a discriminator will classify again. So these adversarial learning is going to happen between generator and discriminator. So types of GANs. So there is a n number of GANs in these GANs architecture. So there is a different purpose. So there is each purpose there is a different GAN, guys. Not only these three, there is a lot of GANs, nearly 20 28 GANs they have. So there is a different architectures of GANs. So style GAN is going to be used generally to style the images. Okay, style generator. So which is going to have some phase generations. So generally used for the phase generations, architecture improvements. And cycle GAN. So cycle consistency loss means nothing but in this cycle GAN, what happens? That loss will come from that image will pass to the discriminator, will pass to the generator, and this will guide in the format of percentages. So this much loss you found, this much loss we found. So in that way, it is going to specify. And big GAN, so hierarchical Latin space, so high resolution images. So it will deal with the high resolution images using big GAN. So like this, we have a number of different types of GANs we have for different purposes. Okay. So application of GAN. So where we can use GAN? Generate a face. So we can generate the faces using these GANs, guys. So using these GANs, we can generate the new faces. Okay, and when we can identify the faces and super resolution images. Super resoluted images we can generate using these GANs. Okay, and AI art. So while you are seeing that image generation models, right? So in that also we can. Okay. So that is the area you can use these GANs and AI arts. So you are seeing that there is a model which is generating a number of image generation models. So there we'll use these GANs. Semantic diffusion. So you already seen this, right? So the people right now they are using some in tools and applications. What they'll do, they'll just apply the things like from celebrities images you can capture, and you can change your themes. So we go with the Avenger movies. So some of the people they change their faces, right? So they changes with their friends' faces. So this is the thing semantic diffusions can be done with the using this GAN. So you can see here that the updated images, there's the change in the images of complete images applying with the different things. So combining these two images, so first and second images, you found the last images. So just first and second, you can find the last image. This is the thing is going to happen using the semantic diffusion. So you can perform using the GAN. So here you can see that. So how the result for image reconstruction. So how the model will understand the reconstructing the image. So here you can see that first image it need to generate. So one layer by layer, I said no, the model will train on layer by layer, it will update. So first few layers you can see the first image. So this is a target image, guys. So first one is target image, and this model try to predict. See, each layer the image is updating, each layer the image update. There is only bed, after that it added some items, after that it added colors, and it is after that it tried to match with the real image. After 8 layers, it has tried to match with the real image. So this is how the image has tried to generate. So now here you can see that there is some images are missing. In the painting, there was some other things are missing. So what that it will do, it will start. This is a main image. Consider this is a main image. So it will start with the different layers. Means this image is going to be considered, corrupted image is considered, and start reconstructing that image. Means it will add the elements with the real image. It will check the real image and it will add the elements. Whereas in the C, you can see the resulting of colorization. So you can convert the image into black and white. You can convert the image into black and white using this concept of GANs. Okay. Color images, you can see that there is a black and white, your grandma's parents, there is a images, right? So you can use some tools, and what we'll do, just we will make it as a colored images. How it possible with the GANs, it can possible. But during these GANs, while working with the GANs, we'll face the issues with these GANs. So what type of issues you're going to face in these GANs means mode collapse. Means mode collapse is nothing but you're going to face the issues that while training the model you are training, no, the discriminator will learn each and every part. Means the discriminator will learn single part of the image, means what is the corner of the image and what is the middle of the image. Every pixel is going to understand by the discriminator. When this generator try to generate new image, it will check that is there any single mistake, single point of 0.099%. If it is correct, also it's going to be rejected. Why? The generator has been trained with a huge data and with a clear cut, with a good accuracy. In that area, so also it will this loop is going to rotate it till end. It will goes on infinity. Why? Because the discriminator has been trained huge clearly. So when the generator trying to generate, the discriminator is not accepting because it has been trained. So it is giving the error. So this is happens. Thing is mode collapse. So while training discriminator, we need to take care. Coming to the vanishing gradient. So this is also one of the problem in with the GANs. So what is the problem with the GANs in the vanishing gradient means? Using vanishing gradient, there will be an issue that, so I already said that there is a weights we'll use in a neural network. While learning CNN, I said that weights are used in CNN. What is this weights means? This is the numbers which will be add randomly to help the model to learn some more complex things. Will help the model to learn some more complex things. So that is the weights we will be neglected. The weights will become zero. So training n number of times, that weights will become zero, and the neurons will be deactivated, and it is not going to generate accurate image. So that is also issue in the training of GANs. And unstable training network or slate unpredictable. So while generating, it's not going to give the accurate image. It's not going to give the best image. So that is also one of the issue while dealing with the GANs. I hope this clear with the GANs. Am I clear, guys? Yeah. So understood how the GAN network is going to work. So in upcoming session, we'll see the practical also. I hope you guys are doing the labs in the alternately. So try to finish the labs, okay? So have you filled the Google form correctly in the right format? Already shown, right? So how you need to give the access in the way of that um, public URL. So have you gave the correct URL? So if you guys are not you are not going to provide the correct URL, then you are going to face issues. I have already shown that how to give public URL, right? The starting of the session, we have already shown that how to give the public URL. Just I will inform to the team, okay? So if you gave the right things, just I'll inform the team that about the credits, okay? Okay, I'll inform the team and let you know. Meanwhile, I just share the different types of GAN. Just a minute. Show that I'll show you some different types of GANs. The purpose of doing lab that Google going to issue the certificate that as a performing these labs. Okay, so you will get to know how this generative AI is helping to the cloud platforms. Okay, so for example, you have a guide. For example, you're working on any of the projects in a cloud, so there is a guide for you to do the task. Like you can perform the operation like creating a cloud storages, servers. Okay, performing operations like data analysis, data scientist, and creating your own models. So there is a guide who will help you with the related issues and tasks. So you'll get to know using this type of going with this cloud. Okay, I mean, it's like working on these labs, you'll get to. So that is the main motto. Just a minute, guys. I'm going to show you one more slide. Okay. You'll get to know. You'll get to know what is that. Guys, you need to do all the modules, 3 modules, just beginner, intermediate, and advanced levels. Need to finish. So do you have any doubts, issues? We'll discuss in the next session. So I hope that you're clear with the GANs. So in the upcoming session, I'll show that how to do it, what are the different types of GANs and variational autoencoders, as well as you will see in a practical too. Okay, in the upcoming session, I'll show that in practical of these GANs, and also we'll discuss about variational autoencoders and how it is going to help. All these things we'll discuss in the upcoming session, guys. Okay, I'll share the 3 courses. I think you know the 3 courses names. So once I'll share it once, just okay. So guys, these are the 3 labs you need to finish. Okay, lab 1, beginner introduction to generative AI learning path. Second was Gemini for Google Cloud learning path, and third one is advanced generative AI for developers learning path. So this is the thing, you 3 modules you need to finish. Okay, so who haven't filled that form, try to finish, try to fill the form. Okay, so you'll receive the credits in 2-3 days. Okay, I'll let you know that, guys, the date or last date to finish that. Just let me give you just a minute. Last date to finish. Try to finish by 8th July, guys. July 8th. Try to finish at that time. Okay. Yeah, these are only 3 labs you need to finish. Okay. There is no other labs. I hope the things is clear. Okay. We'll meet in the next session, guys. Thank you. Have a nice day. Yes, you need to finish all the labs. So if you are facing any issues with the labs, let me know. Okay. Thank you. Have a nice day. Meet in the next session. Bye.